Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 8, Lesson 9, More Work Factoring to solve quadratics. In the last lesson we learned about the zero product law and we're going to review that in just a moment. But it's really an amazing solution technique that allows us to solve equations somehow by using factoring. All right, so that's going to be our whole thrust today, is to do more work with that. Now, it's going to be important that you had some exposure to this from the previous lesson, because obviously today we're going to take it up a little bit of a notch, all right? But let's get into it and review. All right, the zero product law. The zero product law is one of the most important equation solving techniques in math because it allows us to solve some, not all, but some polynomial equations whose degree are 2 and above. Now, in order for it to be used, two important conditions must be true, all right? These have to be true. The first one, the equation must be set equal to 0. It's called the zero product law for a reason, all right? It can't be equal to 12, it can't be equal to 20, right? When the product of multiple things is equal to 0, one of those things has to be equal to 0. That is not true of any other number. If I've got the product of a few things are equal to 20, one of the things doesn't have to be equal to 20, but it is true about the number 0. Now, the other piece of that is the product part, and that's the fact that the polynomial set equal to 0 must be factored. Now remember, right, terminology is important. For something to be factored means that it is written as purely a product of a bunch of different things, okay? So if we've got an expression that is factored set equal to 0, then we can use the zero product law. So let's review how that works in exercise 1. Let's take a look. Solve each of the following equations using factoring. Letter A, x squared plus 2x minus 35 equals 0. All right, well, the good news in exercise 1 is that all of these equations are already equal to 0. All right, so the 0 part of the zero product law is already met. But not one of these three things is factored yet. Now, when we think about factoring, we always have to keep in mind the three major types of factoring. Number 1, right, GCF factoring, and we should always look for that first. Number 2, the difference of perfect squares. And number 3, trinomial factoring, in other words, factoring something that has 3 terms. Now in letter A, where we have x squared plus 2x minus 35 equals 0, there is no GCF. So this is straight up trinomial factoring. All right, now we worked on that a lot in the last unit, so I'd like you to pause the video for a moment and factor the left-hand side of that expression. All right, well, this one's not too bad. We're looking, remember, for two numbers because it's a leading coefficient of 1. We're looking for two numbers whose product is negative 35 and whose sum is positive 2. Those are pretty easy to figure out because they are positive 7 and negative 5, right? And that means, in letter A, this is going to factor as x plus 7 times x minus 5 equals 0. Now, as soon as you have something factored and equal to 0, the key then is that one of these two things has to be equal to 0, right? Or better yet, if either of these two things is equal to 0, then the overall polynomial will equal 0. Well, how can they be equal to 0? Well, if x plus 7 is equal to 0, or if x minus 5 is equal to 0. And of course, these are two equations that you could have solved back in 6th grade math, right? That's one of the cool things. Well, maybe you couldn't have solved the one with the negative numbers, but these are single-step equations, one-step equations, and we get x equals 5 and x equals negative 7. It is very, very important for you to sort of make this connection between the factor and the 0, right? Let me get the line in there, right? If x plus 7 is a factor, x equals negative 7 is a 0. If x minus 5 is a factor, x equals 5 is a 0. By the way, it also goes the other way around. If x equals 5 is a 0, x minus 5 must be a factor, and if x equals negative 7 is a 0, x plus 7 must be a factor. All right, let's take a look at letter B, which is a little bit more complicated. 3x squared minus 30x plus 48 is equal to 0. Now notice this is definitely a trinomial, a three-term polynomial, right? But the leading coefficient isn't equal to 1, it's equal to 3. Now we have a couple choices here. We could factor a 3 out because it is a common factor between the 48, the 30, and the 3, or we could divide both sides of the equation by 3. Either way, we will end up with the same solutions. All right? In the last lesson, I actually divided both sides of the equation by 3. This time, I think I'm going to factor it out. So let me start with that process, right? If I take a GCF of 3 and I factor it out, right, I'll end up having x squared minus 10x plus 16 is equal to 0. Okay. I could still divide by 3 on both sides and get rid of that 3 if I wanted to. But now I need to go ahead and factor this trinomial. Yet again, I'd like you to pause the video and factor that trinomial for me. Take a moment to do that. All right, be careful here. I'm looking for two numbers whose product is positive 16 and whose sum is negative 10. Now, if I have a positive product and a negative sum, it means both of the two numbers must be negative, and they happen to be negative 2 and negative 8, right? Negative 2 times negative 8 is positive 16, and negative 2 plus negative 8 is negative 10. So this is all going to factor as 3 times x minus 2 times x minus 8 is equal to 0. Now, a lot of people get confused at this point about the 3. How does the 3 affect the solutions? Does it change the solutions? And it doesn't, right? The two solutions, we'll get these in a moment, are going to be x equals 2 and x equals 8. The plain fact is, if I took 2, x equals 2, and I substituted it into this thing, right, I'd get 3 times 0 times negative 6, and as soon as I have times 0 here, then the whole thing's equal to 0. Likewise, if I substituted 8 into this expression, I'd have 3 times 6 times 0, which again is equal to 0. So that 3 is having no effect on it, right? The 3 can't be equal to 0, so I don't even need to account for it. And I can now just say x minus 2 is equal to 0, add 2 to both sides, and I'll get x equals 2. X minus 8 is equal to 0, add 8 to both sides, and I'll get x is equal to 8. All right, awesome. Now those two are definitely a couple that we could have encountered on the previous lesson's homework. Letter C though, this one's a little bit more complicated. Let's take a look. We've got x minus 3 times x plus 1 plus x minus 3 times 2x minus 7 equals 0. Now, I want to point something out. A lot of students might look at what appears to be a very complicated expression here and think, oh, it's already factored. Right, I got stuff in parentheses multiplying other stuff in parentheses. It's factored. I'll take this and set it equal to 0, 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 and I'll be good to go. But the problem is this isn't factored, right? And it's not factored because of that plus sign right there. To be factored literally means you've got something times something times something times something times something equals 0, right? It can't be something times something plus something times something. That doesn't work, right? I mean, if x equals 3 is a 0, you know, or if x equals negative 1 is a 0, well, sure, that portion's 0, but this portion won't be. Okay, so you have to make sure it's completely factored. Now, to factor this one, we go back to that day that we spent in the previous unit on factoring by using structure, okay? So I'd like you to begin by trying to factor this one by factoring out that x minus 3 as a GCF. So pause the video right now and see if you can factor the left-hand side of that, all right? Once you have it factored, then see if you can solve it using the zero product law. All right, well, let's do it, right? I'm going to first factor that x minus 3 out of the larger expression, and that's going to leave me with x plus 1 plus 2x minus 7 inside of parentheses is equal to 0. Now I want to do a little bit more. I'm going to combine some like terms in here in just a moment. I can get rid of those parentheses. There's no subtraction between the two binomials, so that's pretty easy. Here I'll have x plus 2x is 3x. I'll have 1 minus 7, which is negative 6, and that's equal to 0. And now I've got this thing factored, right? I now have something times something is equal to 0. So I can take this and set it equal to 0. I can take this and set it equal to 0. I'll do that right over here. Oops, move that over there. We'll get x minus 3 is equal to 0. Add 3 to both sides. And I'll get x is equal to 3. And then I'll take my 3x minus 6 and set it equal to 0. Maybe a little bit more work on this one because I have to add 6 to both sides. And then I have to divide both sides by 3, giving me 6 divided by 3, which is equal to 2. But easy enough, right? It's still the same fundamental idea. I need to factor this expression, which means I need to get it to a point where it's written purely as a product of different expressions. Once I have it as the product of multiple expressions, I can then set each one of those expressions equal to 0 and solve for the variable value that will make the expression equal to 0. It's really cool. And what's really amazing is if you took x equals 2 and you substituted it into this long expression up here, it would be equal to 0. X equals 3, that makes a little more sense because it would make this equal to 0, it would make this equal to 0, so you'd get 0 plus 0 equals 0. The 2 is a little bit more of a mystery, but it would turn out to be a 0 of that expression. All right, let's do a little bit more work. All right, now, the connection between the zeros of a function and its factors is really important to understand. I mean, it is almost the basis of all of Algebra 2, all right? Not so much Algebra 1, but it is definitely there, and we're exploring it right now. Now, sometimes we'll want to use a 0 to help us factor. That's a little bit ironic, because most of the time we want to use factors to find the zeros, but sometimes you want to use a 0 to help you factor. And let's take a look at that in exercise number 1. Louise graphed the quadratic y equals 3x squared minus 5x minus 8 using his calculator and produced the graph shown. He can tell from his graph that x equals negative 1 is one of the function's two zeros. He could not tell what the other 0 was because it did not fall on an integer location, circled. Letter A, write down an equation that would allow you to solve for the zeros of this function. All right, so in letter A, I don't want you to solve anything. I just want you to write down an equation that you could solve that would give you the zeros to the function. Pause the video now. This should be relatively quick. All right, to find the zeros of any function, I mean like any function, you simply take the formula for the function and, strangely enough, set it equal to 0. You don't take x and set it equal to 0. If you take x and set it equal to 0, you find the y-intercept. But if you want to find out where y is equal to 0, you take the function formula, which is what y is equal to, and you set it equal to 0. Now, very importantly, right, letter B, what must be a factor of the expression 3x squared minus 5x minus 8 based on the fact that x equals negative 1 is a 0? And again, just to point out, right, there's my x equals negative 1. Right, on my graph, that one. This is the one that Louise doesn't know, all right? But I do know that x equals negative 1 is a 0. So what must be a factor if x equals negative 1 is a 0? Pause the video now and write something down, maybe even slap it in parentheses. Well, it's kind of like backing it out, right? So if x equals negative 1 is a 0, think about this, right? If I add 1 to both sides, right, x plus 1 equals 0, it means x plus 1 must be a factor, right? It's got to be, right? There's this beautiful connection between zeros and factors, factors and zeros, right? If positive 1 was a 0, then x minus 1 would have been a factor. If 13 was a 0, x minus 13 would have to be a factor. But here's the cool thing. This thing only has two factors, and this is one of them. All right? So letter C then says, use your answer to B to help factor your equation from A and find the other 0 of this quadratic function. All right, so think about this for a second, right? We're trying to solve this equation, 3x squared minus 5x minus 8 equals 0. And this is a more challenging trinomial to factor because its leading coefficient is not equal to 1. But I know one of the factors is x plus 1. So I claim the other factor should be a piece of cake for you to figure out. Pause the video now and see if you can fill in what the other factor would have to be and then set that factor equal to 0 to solve for that other 0 that I can't see on the screen anymore, but that one that isn't an integer. Pause the video now and see what you can do. Well, it's all about our FOIL algorithm, right? We know that whatever we put here multiplies x and gives me 3x squared. So I only have one choice here, right? It's got to be 3x. Now likewise, whatever is sitting here has to multiply positive 1 and give me negative 8. And there's only one number I can put here to multiply by positive 1 and give me negative 8, and that is negative 8. Now I could multiply this out just to make sure it's right, but think about it, right? I'd have negative 8 times x, that would be the O in FOIL, that would be negative 8x. Then I'd have 1 times 3x, that would be the I in FOIL. So negative 8x plus positive 3x would be negative 5x, and I'm golden, right? That now means I can take my 3x minus 8 and set it equal to 0. I can add 8 to both sides, and that will give me 3x is equal to 8. I can divide both sides by 3, and that will give me x equals 8/3, which is a perfectly good way to leave your answer, but I'm going to actually write it in mixed number form. That's going to be 2 and 2/3, right? The reason I like putting it in terms of 2 and 2/3 is that I can now kind of go back up to my graph, right? I can look at this. Here's 1, here's 2, here's 3. That 0 lies somewhere between 2 and 3, closer to 3 than 2, and I in fact found it to be 2 and 2/3. So my 0 here, if I had gotten that 0 to be like 7, well then either the graph is wrong or my 0 is wrong, right? And that's important to note, right? We want to verify our information. All right, now, we shouldn't forget all the work we did at the beginning of this unit solving quadratics using completing the square. So we now have two methods for solving quadratic equations, factoring and completing the square. And I think I mentioned this when we first looked at factoring. Unlike multiplying two binomials together, on standardized exams, they often want you to demonstrate that you know how to solve quadratics using both of these techniques. Now, they won't give you a single problem and say solve it using both techniques, but they might say, oh, with this one, solve using, completing the square. This one, solve by using factoring, okay? So what I'd like to do is actually kind of compare and contrast the two right now. All right, let's take a look at exercise number 3. Consider the quadratic equation x squared minus 2x minus 24 is equal to 0. Letter A, solve this equation using factoring, and letter B, solve this equation by completing the square. All right, well, let's do them not both at the same time, but pause the video now and try to solve that equation by using factoring in letter A, and then we'll turn around and also solve the equation by completing the square. But first, do it by factoring, then we'll talk about that. Then I'll have you work on it, doing it, completing the square, and then we'll take a look at that. Pause the video now. All right, so let's do it. In terms of factoring, well, we've got simple trinomial here, leading coefficient of 1. So I'm looking for two numbers whose product is negative 24 and whose sum is negative 2. That's pretty easy. That ends up being negative 6 and positive 4. So I end up getting x plus 4 times x minus 6 is equal to 0. That gives me x plus 4 is equal to 0, and x minus 6 is equal to 0. And I get x is equal to negative 4, and x is equal to positive 6. Pretty quick, pretty easy, right? So let's now review how to solve it by completing the square. See if you can remember how to do that. It was only a few lessons ago. Go ahead and see if you can solve this by completing the square. Now, you'll know you've done it right if you get negative 4 and positive 6, because the method of solution shouldn't determine our answers, right? The answers should be the answers regardless. Pause the video now and try to solve this by completing the square. All right, well, unlike the zero product law, for completing the square, I don't particularly want this equation equal to 0. In fact, for completing the square, I think the first thing that I would do is I would add 24 to both sides to not have it equal 0. In fact, all I want on the left-hand side at this point is my quadratic term and my linear term. All right, so now remember, I'm going to take half of -2, which is -1. I'm going to square it and get 1, and I'm going to add that to both sides of my equation, right? And I'm just going to immediately say that's 25, okay? This trinomial now can be factored as x minus 1 squared is equal to 25. Give myself a little bit more room. Okay, I can take the square root of both sides. That will give me x minus 1 is plus or minus the square root of 25. That will give me x minus 1 is equal to 5, and x minus 1 is equal to -5. Add 1 to both sides, and I'll get x equals 6. And add 1 to both sides here, and I'll get x equals -4. Okay, so we've got two techniques, both perfectly valid, both perfectly good in terms of solving this equation. Now, again, there's many times when you have to solve a quadratic and it doesn't matter which technique you use. Whether you use factoring or completing the square, that choice is up to you. But you do need to know how to use both of them, all right? Now, let's say that we have a situation, though, where we've got some choice. Although many quadratics can be solved using both factoring and completing the square, sometimes which method we choose will depend on which is easier for the given equation, all right? So let's take a look at exercise number 4. Consider the quadratic equation x squared minus 13x plus 30 is equal to 0. Letter A, which technique, factoring or completing the square, would you rather use to solve it, and why? Okay, so what I want you to do is I want you to think about factoring that left-hand side, and I want you to think about the procedure of completing the square for that particular one. Which one would you rather do? Not which one would I rather do, right? Which one would you rather do? Write that down, right, and give a rationale for why. And then we'll talk about it, and then in letter B, we'll go ahead and solve it. All right, well, in exercise number 3, the last exercise, if I was given a choice on that one, honestly, I could go kind of either way. I really could. On this one, I think factoring is the way to go absolutely positively for one simple reason. That linear coefficient, -13, is odd, right? So if I had to use completing the square on this, I'd have to divide 13, actually -13, by 2, which would give me -13 halves, and then I'd have to square it and add that on. By the way, 13 halves squared is 169 fourths. So you'd have to add 169 fourths to both sides of that equation. If you're not bothered by that, right, that's great. Then use completing the square. On the other hand, if you are fraction phobic, like many people are, including me a little bit, then you would probably prefer factoring. So I'm going to actually write down in this situation, factoring, because completing the square would involve fractions. Again, if that doesn't bother you, awesome. Okay. Generally speaking, factoring to solve a quadratic is quicker than completing the square, but that's all based on whether or not you can factor it. If you can't factor it, then completing the square is rather nice because it's very algorithmic. It's step 1, move the constant to the other side. Step 2, divide b by 2, square it and add it to both sides, etc., etc. It's like dot, 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 dot. Whereas factoring might be more, I gotta guess, I gotta check, etc. Anyway, I'd like you to now pause the video, and if you really wanted to solve it by completing the square, go right ahead here. I'm going to go on and solve it by factoring in just a moment. So regardless, go ahead and try to solve that in letter B, and then we'll talk about the solution. All right, well, I think factoring really works well here because this is a relatively easy trinomial to factor. I always have to say relatively easy because you never know, right? I'm looking for two numbers whose product is positive 30 and whose sum is negative 13. Both those numbers have to be negative in order to have a positive product and a negative sum, and those two numbers happen to be negative 3 and negative 10, right? So I can factor that expression as just x minus 3 times x minus 10 is equal to 0. Then I can set each one of them equal to 0. You might even think this step starts to get a little bit silly after a while, but they want to see your algebra here. By algebra 2, I would hope you would just look at that and say, oh, x equals 3, x equals 10. But for now, let's go through this process, and there we have it. All right, so it's important. It's important to know both techniques because you're very likely going to be assessed on both techniques, but it's also important that when you have choice, you feel comfortable in which one will be easier for you to use. All right, let's go ahead and take a look at one last consideration. All right, to use the zero product law, an equation must be set equal to 0. That may involve some algebraic manipulation initially, all right? So the plain fact is everything that we've dealt with so far, all of the polynomial expressions have already been set equal to 0. But in exercise 5, we're going to see situations where that's not the case. So let's take a look. Solve each of the following quadratic equations using factoring. Letter A, x squared plus 5x minus 43 is equal to 8x plus 11. All right, well, it would be a horrible mistake to just immediately take that quadratic and factor it and try to do something with it because the equation's not set equal to 0. All right, so what I want to do in this situation is I want to get the right-hand side in this particular case equal to 0, and that's relatively easy to do. There's a positive 8x and a positive 11 on this side, and I just need to subtract them away, right? I need to subtract them from both sides of the equation. So I'll subtract an 8x and subtract an 11, minus 8x minus 11. All right, nothing happens to that x squared, but then I have 5x minus 8x, we need to be careful there, which is negative 3x. I have negative 43 and negative 11, again, very important, and that's negative 54, and that's all equal to now 0. All right, so that is the only new twist in this problem. The idea that if the equation isn't equal to 0, you may have to add or subtract things from one side in order to get it equal to 0. At this point, though, this should be relatively easy to factor. I would suggest you don't want to do this one by completing the square because, again, that 3 is odd. But take a moment and see if you can factor this and solve the equation in letter A. All right, well, I'm looking for two numbers that have a product of negative 54 and a sum of negative 3. That means one's got to be positive, one's got to be negative, and the larger one in terms of absolute value has to be negative. Those two numbers happen to be negative 9 and positive 6. So I can factor this equation as x plus 6 times x minus 9 is equal to 0. X plus 6 is equal to 0. X minus 9 is equal to 0. Subtract 6 from both sides, and I'll get x is equal to negative 6. Add 9 to both sides, and I'll get x is equal to 9. Okay, that's it. Now, letter B is very, very similar to letter A, all right? So what I'd like you to do is pause the video now, try to get this equation equal to 0. Once you have it equal to 0, then factor it, set each factor equal to 0, and solve. See what you can do on this last problem. Well, apparently I really like subtracting 11 from both sides of an equation. So in this case, because I have a negative 2x plus 11, I need to add 2x to both sides, and I need to subtract 11. So add 2x and subtract 11. All right, again, nothing happens to that 15x squared. It just kind of hangs out there. Negative 7x plus 2x is negative 5x. And note, 11 minus 11 is 0, so that constant term goes away. Now, we end up getting this particular equation, and we have to kind of look at it and go, wait a second, I need to factor that thing. Now, there are three types of factoring, right? There's GCF factoring, There's the difference of perfect squares factoring, and there's trinomial factoring. And one thing I know for certain, this is not trinomial factoring because there's only two terms. It's a binomial. Now that means it could be GCF or it could be difference of perfect squares. It almost appears to be difference of perfect squares because you have a difference and you have an x squared. But 15 isn't a perfect square, 5 isn't a perfect square, x to the first isn't a perfect square, so no. This is straight up GCF, right? There's a 5 that goes into both 15 and 5, and there's an x that we can factor out as well because there's an x to the first and an x to the second. So my GCF here is 5x. I can factor that out. That will be then 3x minus 1 in parentheses, not just 3x. That would be weird, right? We're reversing the distributive property. Easy to check this, right? 5x times 3x is 15x squared. 5x times negative 1 is negative 5x. We're golden, right? Now I need to set 5x equal to 0 and 3x minus 1 equal to 0. Give myself just a bit more room, so I'm going to take this factor, set it equal to 0. I'm going to take this factor and set it equal to 0. Here I need to divide both sides by 5. 0 divided by any number except for 0 is 0. And 3x plus 1 is going to be easy enough. I'll add 1 to both sides. That'll give me 3x is equal to 1. Divide both sides by 3. And x is equal to 1/3. Way down here, but it is equal to 1/3. All right, that's it. Now be careful, I will get some students who will start to slip into a bad pattern where they'll factor and they'll see a number here, positive 6, and they'll say, oh, negative 6. Negative 9, positive 9. Oh, negative 1, oh, positive 1, right? No, 1/3, right? Because of that 3. I'll even get some people who will see a 5x here and they'll think, oh, x equals negative 5. No, right? Make sure you understand where each one of these numbers is coming from. We are still solving equations once we have it factored. We're not just looking inside of parentheses and going, take number opposite of what I see. Okay, don't go there, right? Make sure you know why you're doing what you're doing. All right, let's summarize. So today, we really just worked on more problems involving the zero product law. And what I wanted to emphasize the whole time was that for the zero product law, two things have to be true. The equation must be equal to 0, and we saw how that played out in the last exercise, and the expression that's equal to 0 must be factored. Once those two things are met, then set each one of those factors equal to 0 and solve the equations that come from them, and you're going to have the solutions to your overall equation. We're going to use this a lot more actually in the next 3 lessons, okay? We're going to be using the zero product law in each one of the next 3 lessons, so make sure you work hard on the homework this evening. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.